I was told not to press the black button because something bad can happen. I really want to try it. So hi everybody. Thank you for being here. Just a quick intro. My name is Adnan. I am responsible for product management and go-to-market for software-defined networking at Dell EMC. So the idea today is to sort of go over, I mean, in 20 minutes, it's a little hard to get into the details, but go over what we are doing with regards to SDN, how we see the digital transformation happening in the industry, and give you a quick overview. I am around till end of day tomorrow. So if you are awake enough that you can remember my name, it's my first name dot last name at dell.com. So you can drop me an email, and we can definitely get into a deeper conversation here. With that, let's get started. I think I'm the last guy between you and lunch, right? So we'll try to keep it interesting. I tend not to follow the slides too much. I use them as reference points, so please forgive me for that. My computer science professor would actually have a heart attack if he finds out that I'm giving a talk on something related to computer science. So with that, let's get started. Let's see if the green button works. Yes, it does. So if you think about it, right, I think right now is a very interesting time in the technology industry, because at the end of the day, if you look at some market research, what is happening is, because of what happened in the cloud, everybody is looking at building infrastructures in a very different way. Because what has happened is the expectation that people have from technology organizations or technology companies has fundamentally changed. Everybody has to go deploy the applications faster. We have to look at security. And I don't know when was the last time people actually had an increase in their IT budgets. So essentially, you have to do more with same, or do more in some cases with less amount of money. So how do you make that work, right? Now, at the end of the day, the way we are looking at it, if you look at some research, right, 73% of the people that we surveyed, or that were surveyed as part of this, actually are now looking at technology as the fundamental driver with regards to their industry. And you can go through the statistics. I mean, they're fairly self-explanatory. They explain themselves. But the idea is that we basically have to look at technology now in a shorter time span, and it is in the fundamental forefront of how we are building infrastructure. So the time for us to embrace this is now. I mean, we've gone through these cycles, and we'll talk about this in a second, that we have no choice but to look at how we prioritize technology in our day-to-day activities as part of our business, and that time is now. And as part of that, I mean, I think a lot of you have seen Dell EMC go through a significant transformation in the last 24 months. We did acquire this small company called EMC. And the reason is because we believe we have to have the right assets to enable this transformation. So what are some of the key drivers for this? You have to innovate faster to maintain your competitive advantage, because if you don't, your competitors will do that, and they will out-innovate you, as it is the fundamental cornerstone of business. You have to move faster. Those days of deploying applications in 6 months are behind us, because as businesses, we are challenged that if I can go deploy my application in public cloud in 20 minutes or 2 hours, why is it that if I have to do it in private cloud or in a hybrid cloud infrastructure, I have to wait 2 months to 6 months while we get the infrastructure ready? So we all agree that we have to go faster. And then to my earlier point, we basically have to drive costs down as much as we can, because that is also very important for us to be competitive. So from our perspective, I'll skip this one, and I'll get to the same slide, to the punchline where I can explain this. So if you take a look at it from an infrastructure standpoint, right, there are 3 main components of infrastructure: compute, storage, and networking. I actually think that the software-defined sort of compute happened. we are running mostly virtualized infrastructures, and that has enabled the innovation with regards to bringing applications on VMs, irrespective of which hypervisor you choose. Containers are coming in very strong, and we see some container adoption happening in large infrastructures as well. So the compute side of the industry, I think, is fairly well sorted with regards to virtualization is concerned, or software-defined compute is concerned. Storage, same phenomena are happening in storage. I mean, we all hear about software-defined storage. We have different technologies that enable that. But networking has always been stagnant. Yes, we did go from 1 gig to 10 gig to 40 to 100. But with regards to how we fundamentally approach software-defined networking, I mean, nothing much happened in the last decade. We were still building those 3-tier architectures, and now leaf-spine is coming in. So how are we looking at networking at Dell EMC? It's pretty straightforward, actually. What we are doing is quite simple. And the reason for showing this slide is it actually sort of gives you the guiding principle that we at Dell EMC use to drive our decision making. Our goal is very simple. We want to make networking as close to compute as possible. A switch should actually look like a server. Now, the problem is, fundamentally, if you want to switch packets at line rate and you have protocols that you have to support, 100 gig switching is not a simple problem to go solve. So the silicon side of the equation is always going to exist. But what we can do is we can abstract that complexity and make networking look as similar to compute as possible, so we can follow the same transformation that happened in the compute side of the industry, right? I mean, most people here in this room are now still deploying x86-based systems, right? I mean, we went 15 years ago from mainframes to the x86 transformation, and I would actually challenge that fundamentally changed the application industry, because you had a choice of operating system that you ran on your compute platform, be it Linux or be it Windows, which made it possible for the application ecosystem to thrive because compute was not vertically integrated. And today, fast forward a decade, nobody ever thought that we would be actually talking about running VNFs on a compute platform, right? So it's very important to notice that, because sometimes when you look at these transformations, you don't believe that it's going to happen because it is fundamentally so different than our day-to-day jobs. But you have to step back and take a look at these transformations and say, OK, yeah, this has happened before. It is happening now, and it is going to happen. It's just a matter of time. Now, we can sort of debate the timeline, but the parallel here is that we are making networking follow the same timeline as compute did, right? Now, how are we doing that? We'll spend the next 14 minutes talking about it, but I just wanted to hammer on this point, so it sets the stage for the conversation. We spend a lot of money on marketing. Please don't blame me on why we call it on the platform 1, platform 2, and platform 3, as it is showing on the slide. But apparently we paid a lot of money to figure out what the right terminology is, and this is what we came up with. So we agree that we went from a mainframe-based computing model to actually a client-server-based computing on x86, and now cloud transformation is the fundamental cornerstone of where majority of the compute platforms are getting also deployed, and how they're building these systems, right? So what is open networking? Our definition of networking is, if you take a look at these building blocks that are showing on the slide, but what we moved towards was, we moved away from developing custom silicon to merchant silicon. What that means is, if you, again, think about it, rather than building our own ASICs, we believe that the ASIC innovation in the industry has come to a point where we don't need to go design our own ASICs. And based on the customer use case, we can actually pick up the right ASIC and build platforms that solves our customers' needs. So the first thing is, you have to start at the bottom of the stack. So Dell EMC, we moved away from developing our own ASIC to merchant silicon. We basically design our infrastructure on open standards-based hardware, rather than these pretty boxes that are very big. But the key differentiator from our perspective is, you have a choice of which operating system you want to run on your compute platform. If you take a look at networking historically, you got this pretty box from either us or our good friends down the road but you could not change the operating system, and it came with a bunch of, the only way you could access the platform was either through CLI or through APIs, but you had no say on what OS you want to run on that platform. And in order for you to truly enable SDN, the first letter in SDN is S, which stands for software. So following the compute model, we decided to break that, and we started giving customers a choice of operating system that they want to run on the Dell hardware. Now, we'll get into that. And then on top of that, you can go with an overlay model. Obviously, as part of Dell technologies, we suggest NSX. And then it ties northbound into your automation tool set. But the key differentiator between us and the rest of the industry is we are the #1 open networking vendor in the world, because we started down this road about 3 years ago, where we started offering different choices of operating system. Now, if you think about it, why offer 4 choices? I mean, I don't have a slide on that, but I'll try to explain it. I basically draw this 2-dimensional line on a piece of paper, which I call the crazy meter, right? You have your Googles and the Facebooks of the world on the extreme right, because they are pretty much doing this all themselves. The traditional enterprise is on the left. Everybody wants to build infrastructures like the cloud guys do, right? I mean, I've been in many meetings, and we all agree that we need to get there. Now, there are a few things standing in our way. One is that the technology, most people do not have a 500 people development teams that can help them do that, right? The second thing is your applications, you deal with a lot of legacy applications. And because of that, some applications are just not ready for it, right? And then the third challenge is that you actually have to go through a digital transformation with regards to your workforce, because you just cannot go from here to here on leaving office on a Friday and coming back Monday morning. You have to slowly move to, I mean, you heard a lot about DevOps, automation, but that does require skill set transformation. So from our perspective, at Dell EMC, our job is to provide you with the right solutions. So wherever you are in this technology transformation, you can go down that journey, but we have to fit multiple buckets of where the workforce transformation is at, right? So with that, I mean, again, drawing the parallel with the compute platforms, we offer 4 operating system choices, and I'm just going to briefly cover that and to explain the point. Cumulus is one. It's a full Linux-based operating system, and it gives you a Linux batch prompt. And the reason for doing that, if you are deploying your servers using Chef, Puppet, Ansible, you have the skill set to actually operationalize this, and you can start rolling out your compute rather than rolling out compute and networking separately, you can roll it out together and tie into the same automation tool set. Now, the challenge in that case is not everybody has those deep Linux expertise, right? So how do you get there? And for that customer base, we basically offered a different choice of OS, which is Big Switch. It is a controller-based model. So essentially, you deploy a controller, and if you look at the traditional chassis that come from all the vendors, you have these 2 RPMs, you have line cards, right? A packet goes from, the brains are in the RPMs, and the line cards are packet forwarders, right? You can take all that functionality, rather than running on a custom box, run the brain on 2 servers in a redundant fashion, and your 1 RU switches become the dumb line cards that forward. So in that case, you have access through the CLI or through APIs, as well as the UI, where you get on the controller and you define your infrastructure, and it talks to the fabric underneath, and it just configures the fabric, right? So think of it, right? If you don't have the Linux expertise, this is a good way for you to get started on the SDN journey. And it provides you with analytics, and one of the other problems it solves is in networking is not when you're deploying, is when there's a problem, everybody blames the network guy. So it gives you the analytics and the tools required to basically figure out where any issue is happening in your infrastructure. The third is Pluribus. It actually gives you the fabric without the controller, because you cannot, if you have a brownfield environment where you are interrupting with the legacy infrastructure, you still need, if you want to go down that road, you just cannot pick everything and throw it out the data center and build everything new, right? So in that environment, how do we basically help you go down this journey? So for that scenario, Pluribus is a very good fit. And the last one is IPI. And the reason for doing that is because the commodity silicon, like I mentioned before, the merchant silicon now has caught up to the point where you have the deep buffers and the deep tables required to run a full MPLS stack. So, I mean, everybody in this room probably deploys those expensive routers. But for most use cases, you can use commodity silicon and run MPLS and move to a standards-based hardware platforms. So, I mean, now if you sort of think about this, and go back to my earlier point that we had to deploy these solutions or develop these solutions to cater to different use cases and the workforce transformation where our customers are at, right? So, you know, if you're a Linux shop, you go with Cumulus. If you are building a greenfield data center and you want to build an IP fabric, you can go with Big Switch. If you're going in a brownfield environment, you can build the fabric with Pluribus, and MPLS is IP Infusion. So same hardware, same silicon, but exposing different functionality based on your use cases. And today, when you buy a server, your application on the compute platform is tied to the operating system. It is not tied to the hardware vendor. Similarly, if you go down this road, if you operationalize one of these operating systems, they support multiple hardware, so you're breaking the lock-in, and you can actually drive costs down because you've broken the network operating system and the hardware boundary, right? Same thing as compute. So that's what we did. We have had tremendous success with it. I think one of the most public references we have is Verizon, where they're deploying Big Switch as part of their NFV infrastructure because they wanted to break the traditional networking barriers, drive costs down, go faster, all the things that we just discussed. I'm just afraid that I won't get to that slide, so I just wanted to point that out. So makes sense how we are following the same model as compute. I'm just looking for some nods so I can move forward. Otherwise, we are going to be here till dinner. So, OK. So what are we doing now? The hardware and the software boundary we have broken. And we have done fairly well according to industry analysts and the customer base we deal with. What is next for networking in the industry? So unlike we are always going to develop our own operating system because there are customers out there that want the Dell EMC end-to-end solution, and we respect that choice. So if you take a look at this slide, in the bottom of the slide, it mentions some of the commodity silicon that we support and we are looking at. But you see there are a lot of silicon choices that are available now, right? We moved to an ONI, which is an open standards-based bootloader, which is part of the OCP, the Open Compute project started by Facebook. So we can actually change the operating systems on the hardware, and we don't have to do a lot of work. So that becomes the bootloader on the networking platform. On top of that, we are supporting this standard called SAI, which is the Switch Abstraction Interface Standard. It was jointly developed by us, a few silicon providers, Facebook, and Microsoft, which is part of the OCP. And the reason for that is if you are, again, I'm going to get geeky because I did get some complaints that sessions are not very geeky. If you're developing an operating system in the networking industry, you are programming the silicon. The only way you can program the silicon is by going through the SDKs on that silicon. And as you can imagine, as we have multiple silicon choices, every SDK is different. So it is very hard, and it takes a lot of development resources for us to move our operating systems from one silicon to the other silicon. So we worked with the industry leaders and the cloud providers to develop a standard. I mean, think of it loosely as an equivalent to the x86 standard on the compute side. So the operating system talks to the standard, and underneath does not care about which silicon there is. So we can actually go faster. So if you have an application that runs on top of the OS, it is completely abstracted from the silicon that exists underneath. So I think if you think about it, what Dell EMC is doing to drive the industry forward from an open networking perspective, it's pretty cool. That helps me get over my jet lag when I'm on a plane most of the time. So we did that. Now, the other thing that we did was we basically contributed the operating system to the open source community under Sonic as part of the Microsoft project, which is in OCP, and also in the OpenSwitch project in the Linux Foundation, right? Why did we do that? Because if you have the operational capabilities to run an open source-based software, which, by the way, is the same software code base that we use in our enterprise stack that we sell to our enterprise customers, so we have to fix the bugs, you can do so. It helps you drive costs down. You don't have to pay us a dime for it, but it depends on where you are with your expertise, right? And the second reason for doing that, and I'll stop at this slide because I have about a minute left, what we are trying to get done, and if you take a look at this side of the slide, we want application providers to develop their applications on top of the open source code that we have put out and give them a way to go to market directly with the customers. Why is it that you can only get the applications that Dell EMC supports? Why is it that you cannot pick the application that you want to run? Think about compute. You go buy a server, you put Linux on it, then you go decide which application for your business you want to run on the server. You can't do that on the switching infrastructure today. That is what we are trying to get done. And we are working with application providers, and you will see some of this coming on, where they are working on putting their applications on top of the open source code base and offer that as a paid application to our customers based on the use case. So if you have a rich enough application ecosystem, you can actually, first of all, only buy the applications that you use in your networking, which you can't do today. You go pay a bunch of money to somebody, you get this operating system, and you get these features, and you probably use 20% of them. Right? So now, that is what we are trying to get done. Now, how can we convince application providers to actually port their applications on top of our OS? People are not going to do that if it is a closed system, and it only supports one hardware. Hence, the reason for going open source, so we can enable these application providers to make the investments to port their applications on top of our OS. So with that, I'm almost out of time. I'll just stop here. I knew I wouldn't get through the slides completely, but I wanted to sort of give you an idea. So there are 3 takeaways. We want to make networking as close to compute as possible. The first step, we broke the lock-in between hardware and software. You have the choice of which operating system you want to run. With regards to our own operating system, we contributed it to the open source community, and we are working with the application providers. Think of it like BGP application, MPLS application, analytics, BGP EVPN. And we are basically enabling that application ecosystem, which will come to you as certified applications from Dell EMC. So with that, I'll just pause. Please find me while I'm here. Hopefully, in 20 minutes, I gave you a crash course on what we are doing on networking. I think I'm over by a minute. Thank you. Enjoy lunch. Enjoy Amsterdam. And have safe travels back home wherever you're going. Thanks, guys. Enjoy lunch.